Hi guys, welcome back. Today we'll be looking at forms and working with inputs in Android using Jetpack Compose. Almost all Android apps require some data from the user. We make use of form inputs to collect this data. This makes the inputs an important part of the application. In Android, we have several types of inputs which we'll go through in this video. I will also show you some of the challenges I faced when working with forms and how I use the FormBuilder library to help me solve them. But first, let's go over the basic inputs in Android. I have a simple Android application set up in my Android Studio, so go ahead and create one, then let's get started. The first input is the text field. Just as the name says, it receives alphanumeric data and it's the most common input. This field has two required arguments, the value, which is the text that is shown in the field, and the onValueChanged callback, which is executed once the data in the field changes. We can customize some of the properties and styles of the field. We also have a different kind of text field called the outlined text field. If you run the application as it is, you'll notice that the text field cannot be edited. This is because we are not updating its state whenever the value changes. For that, we create a state variable to hold the value in the text field and update it every time the onValue callback is executed. We can also specify the keyboard type to enforce various keyboard layouts when the user is entering data. For instance, we may need the user's age. This means that we only need numeric data from the user. We can set the keyboard type to number so we don't get any letters in the keypad. The next field is the checkbox. This field provides the user with a set of options to select where they can choose one or more options. This means that the field handles a collection of data. We first create a set of options to present to the user. Then we create a second list that will hold all the selected values, or in other words, the state. This field has two required arguments. Checked is used to show whether the option has been selected or not, and the onChecked change callback is called when the checkbox is clicked. The callback has a Boolean lambda argument that represents the previous state of the box. You can also edit properties of the checkbox like colors and borders. The last field we will look at today is the radio button. It works similar to the checkbox, but instead of selecting multiple options, the user can only select one option. For this, we also have a set of options for the user. We will also have a variable to hold whichever option the user has selected. It also has two required arguments. The first one is selected, which shows whether the field is selected or not. The onClick callback is called when the field is, clicked. So we update our variable then. And just like the checkbox, you can customize the colors and other properties. Now that we have our fields, users can now add their data and submit it. Sometimes users can make mistakes when inputting the data. They may enter a wrong email or not fill in some of the inputs. Or when dealing with passwords, we may want the value to match several criteria. Pretty sure you've seen this. For that, we need to perform some validation checks before we can submit what the users have provided. In our sample form, we will need to check if all the details were filled and that the email was in a correct format. In the buttons on click, we can perform our validation checks, and if anything is missing or incorrect, we can update the UI with the corresponding error message. We begin with the first field and check if it's empty. A good way to inform the user about this would be to highlight the field and display an error message below it. So first, we create a variable to hold the error message and another one to conditionally show the error message. To highlight the field on validation, we can make use of the isError parameter. We also display the error message. Back to our validation, we update our two variables. When you run the application and click submit, you can see that our first validation is working. Next, we check if the email matches the email regex. The other fields have only one validation required, so let's add the checks. Now that we are done with validations, we want to submit this data. In my project, I have a data class that holds the data from the form. However, there are some fields that are of a different type. Age is an integer and Android Lover is a Boolean, but in our form, both of these fields are represented by a string. This means that when submitting the data, we need to convert it to the required type. For the age, Kotlin provides the toInt method, and for the Android Lover, we can just have a simple if statement. And with that, we can submit our data. Now, this is a simple page with only 4 inputs. We don't really get to see a lot of challenges when handling this form. But imagine someone making a survey application or an application with a lot of inputs. There'll be a lot of variables and validation will be one large function. Lucky for us, there is a library called FormBuilder. It helps with state management, validations, and transformations of our data. The library does this by separating different states available in a form. Each input can get its own state class. This class holds the input value and errors if any. It also has some methods to update the value, transform the value, and validate the value. The library has some predefined validators. More on that in a bit. All of these states are held within one form state. This form state handles all the data in all of our fields. This means that we can use it to validate all the fields at once, as well as get the data from all of the fields. To get started with the library, add the dependency in your build.gradle and sync. In your view model, you can create a form state variable to hold all your fields. The first field we will look at is the TextFieldState. Just as the name states, it's a state that holds text data. This is more suitable for text fields. It requires a unique name to identify the state in our form state. We will also use this name when getting data from the form later on. We mentioned validators earlier in the video. These are used to define the validation rules for the specific input. You can have more than one validator in a field. We have validators like email and required, which are pretty common. Email uses the RadioButtons to verify that an email address is of the correct regex. The required validator is used to verify that the field is not empty. We also have the custom validator, where you pass your own custom implementation. Pretty customizable if you ask me. For our email field, let's go ahead and pass in the two validators we mentioned. We can also create another text field for our age field and add the required validator. To use these two states, let's go ahead and get them in our activity. First, let's get the form state from the view model. The form state class has a function that gets a specific state based on the name. Let's update our text fields to use the state's values. We can also access the error details from the specific states. Lastly, we need to update the states once the user changes the input's values. The next state is the SelectState. This handles collections of data where the user can select multiple options. You can easily guess where this state is used. We can use it within checkboxes since they fit this use case. It has similar methods as the TextFieldState. Let's go ahead and add it to our form state. Then in our activity, let's update the checked field and the unchecked change callback. We also need to update our error handling. The last class we'll look at is the ChoiceState. This is used with the RadioButtons since they only allow one option to be selected. If you look at this class, it extends TextFieldState instead of base state. This is because it holds a single string, just like the TextFieldState. Let's add it to our form state. Same story in our activity. And with that, we have added the various states in our form. We can now validate the data and send it to our view model. Let's clear our manual validations and just call the formState.validate function. This function returns a Boolean value. It's true when all the validations have passed. You can run the application at this point and check if all validators work. And it works! There's one more feature in this library that I'd like to go through. Remember, we have the data class for our data. We can actually get data from our form using this format or in this type. There is a getData function that converts all the data in our field to the specified data. This is a really cool feature, but when we run the application, we get an error. This is because our age is in the form of a string, but the data class expects an integer. This is where transformers come in. We can specify a transformation function in the specific field, and once we request data from our form, this method is executed and we get data in our preferred type. So in our view model, we can specify a transformation function for the age. We get the input value as a lambda argument, and we can now return whatever we want. We also have another field that needs transformation. Our Android lover field requires a Boolean. So as you can see, this library provides some handy tools to work with forms and inputs. We have reduced our code and our composables are now cleaner. The library also has some useful tools like transformations and easy ways to perform validations. There is more information about the library in the docs and the reference. I will add all the links from this tutorial in the description below. And that's it about the FormBuilder library. If you like this content, here is more that you might like. I'll be posting more content later on, so subscribe to be updated. See you next time.